Welcome to the fourth part of VCAA Specialist Math 2022 exam papers. In this video, we will solve exam paper 2, section A, questions 1 to 5. Statistically, most students did well in questions 1, 2, 4, and 5. As for question 3, it is not difficult to find at least one vertical asymptote after simplification.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math exam paper series. This is 2022 exam 2 paper, which consists of 20 multiple choice questions in section A and 6 extended response questions in section B. In this video, we will present question 1 to 5 in section A. Let's start with question 1, which states that for the interval x is greater than or equal to 1 over 2 but less than or equal to 3. The question is to find the right function from 5 given choices that match the graph of y equals modulus of 2x minus 1 plus modulus of x minus 3. As it can be seen, the modulus of 2x minus 1 is expressed to 2x minus 1 when x is greater than or equal to 1 over 2, and the modulus of x minus 3 is expressed to 3 minus x when x is less than or equal to 3. Hence, when x is greater than or equal to 1 over 2 but less than or equal to 3, modulus of 2x minus 1 plus modulus of x minus 3 is equal to 2x minus 1 plus 3 minus x, which equals x plus 2. So the answer for question 1 is C. Question 2 is to simplify the expression 1 minus 4 times the square of sine x over the sum of the square of tangent x plus 1. Because 1 over the square of cosine x equals the square of tangent x plus 1, it gives that 1 minus 4 times the square of sine x over the sum of the square of tangent x plus 1 equals 1 minus 4 times the square of sine x over the reciprocal of the square of cosine x, which equals 1 minus 4 times the square of sine x times the square of cosine x. Because 4 times the square of sine x times the square of cosine x equals the square of sine 2x, it brings that 1 minus 4 times the square of sine x times the square of cosine x equals 1 minus the square of sine 2x, which equals the square of cosine 2x. So the answer for question 2 is E. In question 3, the rule of the function is y equals x squared plus 2x plus c, or over the result of x squared minus 4, where c is a real number. The question here is to find the statement which best describes the function graph. According to the rule of the function, it can be written to x squared minus 4 plus 2 times the sum of x plus 2, then plus c, or over the result of x squared minus 4, which is expressed to 1 plus 2 over the result of x minus 2, then plus c over the result of x squared minus 4. Hence, it can be seen that it has a horizontal asymptote y equals 1, and vertical asymptotes x equals 2 and x equals negative 2, if c is not equal to 0. However, when c is equal to 0, there is only one vertical asymptote, x equals 2. So, it has at least one vertical asymptote. Therefore, the answer for question 3 is E. Question 4 shows a polynomial function p of z with its factorized form z minus a in parentheses times z minus b in parentheses times z minus c in parentheses. And accordingly, it has complex roots a, b, and c, where the real component of c is not equal to 0, while the imaginary component of b equals 0. When expanded, the polynomial is a cubic function with real coefficients. The question here is to find which of the given statements is necessarily true. Since the cubic polynomial function can be expanded to the form open square bracket z squared minus the sum of a plus b times z plus ab close square bracket times z minus c in parentheses, which equals z cubed minus the sum of a plus b plus c times z squared plus the sum of ab plus bc plus ca times z minus abc. Since all coefficients of the cubic function p of z are real coefficients, according to the conjugate root theorem, p of z has one real root and two conjugate complex roots. Since the real component of c is not equal to 0, while the imaginary component of b equals 0, it follows that b is a real number, while both a and c are conjugate complex numbers, which implies that the modulus of a equals modulus of c. Therefore, the answer for question 4 is B. In question 5, we let z equals x plus y, where both x and y are reals. Z is a complex number. The question is that if the argument of z minus I equals 3 pi over 4, which one of the given relations is true? Based on the argument of z minus I equals 3 pi over 4, the Argand diagram is drawn here to illustrate the gradient function of the ray is -1. Hence, the corresponding line equation is y minus 1 equals -1 times x minus 0, or in parentheses, which is simplified to y equals 1 minus x, where x is less than 0. Therefore, the answer for question 5 is A.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.